what were some of the architectural considerations, right? I'm sure there is a lot of evaluation of how we want to approach building a system like this, what the components look like, what languages we're going to use. We probably ruled certain things out because they didn't serve specific needs. So maybe talk about some of the architectural considerations that drove how we've built what we've built, and then I'll dig in there a little bit further.
Well, okay. For sure, we love to use Golang for our internal engine and also for our backend language as our backend language, because we understand that Golang was designed to be, first of all, it's a compile language. After that, it's designed for concurrency problems, and we are dealing every day with a lot of concurrency problems. And but going more, not just in the picture to be a performance tool because we are working with a good programming language, because maybe you can do the same with other ones, maybe in a more complex way. But I think that is more the way that we design all the orchestration part in the way that we can scale in the different pieces as needed, and also managed by a central point, just to give you that power that we have been mentioning before, in order to say, okay, I want to do these alerting use cases in my edge that is GCP, and I want to use and I want to create this kind of alerts in my AWS instance, and the way we design the different pieces to grow, and also that central orchestration part. But it's just our orchestration. It's not the data. It's not going through the central point. That this kind of decentralization, and also that centralization in the control plane way, are giving us a power that is pretty hard to make in other ways.
Everything that Lucas was describing is a function of the ability of having a direct function of the ability of having real time. So it's kind of a paradox as well, that a lot of industries with sensitive information, with sensitive processes, have been running without real-time alerting and real-time processes for a long, long time. And we all know what that means in terms of the ability to react quickly to some issues. Having real-time capabilities, having that capability of being able to take decisions as the data gets into your data ecosystem as soon as possible, in order to take actions as soon as possible. And probably another tool will have to kind of take other actions farther down the line. But having those real-time capabilities are basically essential in order to be able to architect what Lucas was describing.
We were trying to use different tools before create our own engine in order to be able to process millions of events per second, and doing tests with different programming languages, with different kind of architectures, just to try if our idea was the resilient one. And we were trying different protocols in order to serialize information coming across our different pieces. And we were creating almost from zero, because the data processing is our business. It's the thing that we need to spend time looking at. And what was the goal? Consume the less possible, to be able to process millions of events per second with the less infrastructure needed, with the less computation needed. Because of what? Because we are helping customers to reduce their amount of infrastructure that they are using if they're in their premises, and to be more competitive if we are in a SaaS. Maybe another competitors that want to do the same thing that we're doing, maybe they need many times more of just computation in order to have our same level of workloads.
Right. And building to what Lucas was saying, so open source works well whenever you have a small problem to solve with a very small scope to solve, and you want to set it up soon. It is attractive. Let's say tempting is attractive. You're able to, there is a lot of community around it. But when you want to get serious, we are talking about petabytes scales of data here. Is when you try to plug in different open source components, is when you start to see that there is no efficiency, because there are components that may kind of plug one with the other, but you start losing efficiency. And efficiency and scalability as a function of that is key when you're talking about the scales of data.
Yeah.
We are talking about having to pull up way more infrastructure to solve the same problem, having to deal with bottlenecks that may take your ingestion down. As I said before, ingestion is a critical system in any company. So, and that happens in previous experiences for us as well, that open source is tempting at the very beginning.
Yeah.
And when you want to have a performing end-to-end solution is when you have to, roll your sleeves and start building that yourself, because we have that experience that is way more performant, because you're focusing on solving the end-to-end problem, no just pieces of it and putting those together, which is more is what open source is